Good evening, everyone, and welcome back to the another session of IoT and Advanced Drone Learning. And good evening, everyone. We are going to wait for a few moments so that the all participant can join with us, and then we are going to start the session. And today's session is going to be the one of the most important session in this series of these classes. We have to understand, sir, Blinky IoT connection, is this possible only from smart devices? Actually, yes, because if you want to connect the Blinky cloud, means you need to access the internet. So yes, on that time you have to use some smart devices. But if you want to make something that can work on IoT, means a non-smart device, you can convert in a smart device. Means if you want to make a non-smart AC into a smart AC, so you can do that. But if you want to control that air conditioner, or if you want to control that non-smart device, so the remote control setup has to be smart. Good evening, everyone. Very good evening. We are waiting for a few moments, then we are going to start the session. And I am apologize for the voice. I think it could be laggy right now because my health is not well. So if any error on the voice, so I'm sorry for that at the very beginning of the class. So we are wait for a little bit, then we are going to start the class. Okay. Technically, the bulb is not smart. We create the device that help to act the bulb, that the bulb is acting like a smart. Okay, means we are going to give a potential to that bulb so that it can act like a smart bulb. That is the point. So basically, what caused the IoT? It's very cheap. That's why I am not using RPI, because RPI is cost around 3,500 or 4,000 rupees. We using Node MCU or ESP32. That is a very cheap microcontroller that you can purchase. It could be around 300 rupees, or 300 or 350 rupees you can purchase from Amazon also. And the relay module which I'm using, it could be cost around 50 to 60 rupees. That's it. Okay, you have already your mobile charger. You can power the microcontroller with your mobile charger. That's it. How you connect the bulb with the program, that I didn't get it. Okay, don't worry at all. Okay, because in a 4th of March means confusion in the practical. Don't worry at all, because we are going to perform the practical again. Okay, at the end of the session, means the 4th of the March, we are going to perform the practical once again. But in this practical, we are including more gadgets and more devices. Means we can use multiple bulbs, or we can use different type of gadgets like bulb, bell, a fan. Okay, these type of gadgets we are going to use. So that we are planning that at the end of the session, we are going to give you a quick revision and a quick overview of the practical, that how we can build the IoT setup. And on the basis of IoT setup, what steps we used over there, what cost of the sensor kit. It's depend upon how, what kind of sensor you want to purchase. For example, if I'm talking about a DHT sensor, DHT sensor, I think it's cost around 80 to 90 rupees. And if you want some temperature sensor, so a few temperature sensors, that is costly, but in general, it could be cost around 100 and 150 rupees. So electronic components are very cheap. You can easily buy it from Amazon, or you can buy it from RC Mumbai. Is small size relay are available that can put inside the switchboard? Actually, let me turn off the screen. I hope you can see me. So just give me a second so that I can bring the relay module for you. So I can represent the size of that, okay? Okay. So there it is. Now you see the size of the relay module. It's the size of my thumb. Okay. Means if I put the relay module behind my thumb, you can't see it. Just imagine how tiny it is. Okay, so yes, we have few relay modules, few setup. For example, this relay module, this is a 4-channel relay module. You can easily place this relay module into a switchboard. Okay, because we already did that. These projects are already done. You can easily do that. Okay, this size could be means it's not about my palm even. Means you can measure it by 3 fingers. Okay, so it size about 3 fingers. That's it. So it's very compact in size. You can use that. And similarly, if I'm sorry, if I'm talking about the Node MCU, it's also very small in size. I think it could be around my 2 fingers. Okay, see, it's not about the entire finger size also. So 2 fingers, or it could be size of my thumb. So these are very small in size. You can easily put these things in a switchboard and make your traditional switchboard into a smart switchboard. You can do that. It's very easy. Okay. But don't worry about the practical, because we are going to perform the practical once again at the end of the session. Okay. So I think maximum participants are connected right now. So now we can start our session. So technically, at at the very beginning of the session, I already told you that this is not only just a theory session. We are going to understand the practicality of each and every aspect of these technologies. Means if I'm talking about IoT, what hardware we can use, how we can use that, how to fabricate these things. Similarly, if I'm talking about the drone, so in last session, we talk about how many type of drones are available. What are the structures? We understand that yes, this is a fixed wing drone, this is a fixed wing hybrid drone, this is multi-copter. How these drones are going to work, we understand about these things. And similarly, we get the point that they have motors, they have this thing, and they have that component. So right now, we are going to learn and understand what component we should use. That is the first thing we have to understand before we start this session. We cannot put any motor over there. We cannot put any circuit over there. There are some rules, some specifications, some parameters over there. Okay. Making a drone is not a kind of easy thing. It's true. It's not a kind of easy thing. Otherwise, everyone can build a drone and that's going to fly very smoothly. Okay. What's happening when we are trying to build our first drone? Okay, when we are trying to build our first drone, it is very much possible that it's gonna start flying. But the problem is that there is no stability. While you are put the throttle, throttle means when you want to lift the drone, what's happening? It is going to wobble like this. And if you want to move the drone forward, then what's happening? It's not going to move forward, it's going to move diagonal. These are the problems we are going to face while we are making the drone. Okay, and in majority case, we saw the drone couldn't even lift. Yes, in majority of the case, the drone couldn't lift. What happened over there? If they want to lift the drone, then what will happen on that time? It is gonna flip or it's going to wobble, or it's going to rotate on its axis and crash immediately. So now we are going to understand why these things going to happen. That is the first point we have to understand. And to build a drone, what point we have to make sure that we are going to put these things correctly. That is the key that we have to understand to build a perfect drone that can fly for us. And the most important thing, our point has to be proved that we build a good drone. Good evening, everyone. Good evening. So that is the thing we have to understand first. Before I gonna start this session, I need you to think that there are four people at the four corner of the table. Okay, just imagine. Okay, right now we are going to start a conversation with each other. Okay, I'm going to give you a hypothesis. Before I'm going to start this session, I have to give you a hypothesis so that the concept and the point of this session has to be clear. Okay, now listen up. So what's happening here? We have a table, and the table having the four corners, and we have four peoples. Okay, four different type of people. One is a strong person, another is a very aged person. Good evening everyone. From chat box. Good evening, everyone. And another side there is a kid, and another side there is a little girl also. Okay, we have different type of people holding the table. Okay, now we are going to ask them to lift the table. Okay, they are going to lift the table. Fine, no problem. So what happened on that time? They are going when they are going to lift the table. Now we are going to put a ball at the center of that table. Listen very carefully. We are going to put a ball at the center of the table, and we are going to give them a command. The ball shouldn't be fall from that table. That is the rule. You have to balance the ball. How you gonna balance it? That's on you. Okay. Now what's happening? If the ball rolling this-ward, they are going to lift the table. The ball is going on that direction, they are going to lift the table like this. So the ball is going to move all around with the table. But the problem is that if there are two strong people and there are two weak people over there, then what will happen on that time? The strong people can lift the table much higher, and the short or the weaker people couldn't lift the table at that much amount. Then what will happen? The balance of the table is going to be tilted, and now the ball is gonna fall on that direction. So what is the point of this conversation? The point is that if we want to build a system, each and every component has to be synchronized. First point. If they are not synchronized, non-synchronization means, what is the meaning of non-synchronization? For example, we put same situation, but all persons are same right now. All persons are same in size, same in height, and same in power. But the point is that they are not listening each other. Okay, they are not listening each other on that time. Then what will happen? Still the ball is going to fall from the table because there is no synchronization. Means there is no communication. Similarly, when we are going to build a drone, each and every component is going to talk with the microcontroller or the flight controller. Technically, that the name is flight controller, but the circuitry is going to work in it. That is microcontroller, or in advanced flight controller, there is a processor also. So the thing is that we have to understand, if we want to build the system, it has to be synchronized. All the parameters has to be correct. Means if we are using a motor, That means all the motor has to be in same power, or if you are going to change something, the design has to be changed also. Okay. So right now we are going to start building the concept of the drone, how we can build that, what parameters we have to follow, and the most important thing, how we can go to the root of these things. Okay, so let me share my screen for you so that you can start learning this concept. All right, so right now we are going to talk about the first component of the drone is motors. Yes, this is the motor right now we are going to talk about. So I hope you can see. Good evening, everyone from the chat box. Good evening, everyone. Okay. So now on the screen, I'm representing some image of motors. The point is that this is not a journal motor, okay? Or this is not only a DC motor. What is it? Why it is looking like some disc or flat something or a flying saucer type material? So we have to understand the concept first. Technically, this is called BLDC. BLDC means brushless DC motor. But the point is that brushless DC motor, I understand few people knew about that already because they belong from electrical and electronic background. So we know about the BLDC. But few people from CS background or from different background, they don't know about the BLDC. For them, first I'm going to explain what is BLDC and why we use the BLDC in this drone. What is the necessity of it? That is the first point. And then we are going go deeper and find out what criteria we have to learn and understand in these things. Okay, so the name justify the point, brushless DC motor. Okay, the question is that, so brushless, sir, what is, I think someone is right, if possible, provide the PPT of this session. Definitely, definitely. All PPTs will be provided at the ending of the session. IoT's PPT with programming, with the circuit diagram, and the drone PPT with all entire concept of these parts, and there are few more PPTs are available. So all kind of PPTs will be sent to you when at the end of the session, means it could be 3rd March or it could be 4th March. Video available, sir. I don't know about the video right now. Okay, sorry for no, it's okay, it's okay. You can ask question, that is a good thing. Okay, yeah. So I don't know about the videos. So what we need to do, just you have to drop a mail or message that the team can provide you the video. They are going to give you the response. Okay, yeah. So right now we are going to understand about the BLDC, how the BLDC works and why the BLDC, why the BLDC. And if it is BLDC, brushless, so it means, for a layman word, it means, is there any kind of motor which having brush also? Yes, of course there is a motor which having brush. Okay, please share contact number. Okay, the contact number I don't know. It is gonna share on the group. Is the point or not? But you can ask the team member. They are going to give you some points to contact. Okay, yeah. So right now we are going to understand how we, please give the link of the study more. Yes, definitely. We will provide the link, and we are going to conduct some summer training also. Means on that time we are going to elaborate each and everything that how to create these windings, the RPM controlation, and stacking of these things. So that's gonna be way deeper concept over there. Most welcome, most welcome. So let's begin with it. Okay. So Right now, what we are going to do, we are going to learn about the BLDC. Before we are going to start the BLDC, we have to understand the brush motor first. Okay, that is the point. We have to understand a brush motor. What is a brush motor? So let me switch you to the brush motor scale. Okay, right now the image I am going to represent, everyone I presume that everyone can familiar with this motor. Okay, everyone knows about it because this is the one of the basic motor you saw in your childhood when you open your toys and fetch out these motors from it. So this is a basic DC motor. Okay, basic DC motor. So technically, if I'm talking about a DC motor, a motor which work on direct current. Okay, if someone don't know about direct current, so technically there are two type of current right now we are talking about, which is a alternating current. Okay, means there is a alteration. You have a positive cycle as well as a negative cycle. And if we are talking about direct current, means it is going to be either in a positive cycle constantly, or it will be in a negative cycle. There is no flipping over there. Okay, means the cycle is not going to be change, means the if there is positive voltage, you constantly get the positive one, and if there is a negative cycle over there, you constantly getting the negative cycle. They are not going to be flipped. That's the point. So right now we are going to understand these two motors. So this one is the brush motor. Why this is called brush motor, let me explain. Okay, the theory is written over there, you can read and you can take the screenshot, or I'm going to give you the slide also. But let's understand about the brush. What is a brush? So before we are going to start, let me explain what is brush, how the brush works. So this is a short diagram of the DC motor. Okay, so over here there are technically two carbon brush which connect with the commutator. Okay, now the question is that, sir, what is commutator? What is a commutator? Why we need the commutator? So technically this part, okay, which part? This part, this one, okay, that one. This entire part means this and this drum. Okay, it could be an armature coil also. So technically this is known as a rotor. Okay, in normal DC motor this is known as rotor. Why it is called rotor? Because it is going to be rotate. Okay, means when you are going to give power on these two carbon brushes. Okay, for example, I'm going to put a positive supply over here and I'm going to give a negative supply on this carbon brush. Then what's going to happen? The motor is going to be rotate. So I'm not going to go to the electrical part in deeper, that how the magnetic field is rotating and how this is going to work. So in simple layman words, we can say when we are going to put the current in the carbon brushes, then what will happen? The armature produce a magnetic field and an outer body contain the permanent magnet. Then what will happen? The DC motors is start rotating by the push and pull. But the point is that there is a physical contact. This is a physical contact. Means if I'm talking about a carbon brush, this is a physical contact which is created to transfer the current. To transfer the current to the commutator for the armature winding. Because without current, we cannot create the magnetic fields. That is the issue. Okay. So the point is that now let me go to the next image for you. So right now, if I'm talking about this image, I hope everyone can able to see this image. So over here, now you see this is the armature winding. Okay, this is a dissection of the motor. Okay, this is armature winding, and over here this represents the contact points. Okay, which touches the commutator. Where is the commutator? At the center of the armature. Let me zoom this for you. There we go. I hope now you can see this very clearly, that part, okay? I'm talking about this one. This is the commutator. Now what they are going to do, they are going to put electricity, the current, into the commutator so that the motor can start rotate. And that is the physical fault, first physical fault we are going to talk about, okay? That is why this motor is known as what? Brushed motor. That is why this is known as brush motor, because due to these contact points, these act like brush. But there is a question. Why they called it a carbon brush? What is carbon brush? Why they don't do any different iron brush or brass brush over there? Because carbon is a very soft element respect to the copper. So while they are going to move, so if we put a harder metal than copper, then what will happen? The computer get damaged. So on other hand, the carbon will gonna damage. Yes, it's gonna wear and tear. So after some time, you can just put the carbon brush, remove it, and put a new one. The motor gonna start work again. That is the thing. That is the point about the brushed motor. That is the point about brush motor. Okay. But if I'm talking about a BLDC, if I'm talking about BLDC, there is no brush in it. Means that brush has been removed. Okay. But the point is that if the brush is removed, then how the motor is going to work? So that is why these motors, these BLDC's motors are known as electrically commuted motors. That is the point. So how the entire scenario is going to be work, I'm going to explain step by step and one by one. Now listen up. Let's go back to the point why we are using the BLDC in drones. Now listen up very carefully. The points why using BLDC. The very first point. In drone, we need to change the speed frequently. Frequently, we want to change the speed. Okay. And I'm not talking about in a low RPM. I'm talking about in a very huge RPM. Okay. In a very huge RPM, we are going to change the speed constantly. Okay. Constantly, the motor RPM is changing. Means the speed of the motor, speed of the blades are changing. Okay. Now the question is that, sir, why the drone is going to be changed? For example, the drone is still at its position. If the drone is still on a same position, then how you can say the speed of the motor is changing? Listen up. Why it is happening? For example, what the drone is doing? The drone is going to stable itself in a certain position. Okay. But there are few factors which affecting the drone to getting the problem, means they are creating the problem to hold the position. What are the factors? Wind, that is the first. The weight of the drone itself, the vibration done by these motors, propellers. So they are the factors already present. Or for example, if you want to put finger on the drone, or if you want to push the drone like this, on that time what's happening, there are, if I'm talking about wind, the wind is continuously try to push the drone, and the drone is try to get the position and make it in a same place. So what it try to do, it constantly change all the motor RPM so that it can stable in a certain position. That is why we are trying to say that the drone motor constantly change its RPM. That is why the first point we need the BLDC. That is the first point. Now the second point. When we are using a normal brush motor, then what will happen on that time? When we are using a brush motor, it's going to give us a wear and tear. We know that because the carbon is going to be damaged due to the rotation, everyone knows. So Now we are going to talk about a huge RPM. Means I am talking about more than 7,000 RPM. I'm talking about more than 7,000 RPM. Okay. So just imagine, means our motor is rotating at more than 7,000 RPM. Then what will happen on that time? The brush which we are using over there, it's not going to hold for a long time. Means the lifespanning time of those motors are going to be very less. That is the first point. Second point, in general case, in normally, normal brushed motor couldn't achieve that amount of RPM even though. Okay, if I'm talking about a racing drone or the RC drones, so they are in a huge RPM. In further means in further slide, we are going to understand how to find out the RPM of the drone. I'm going to tell you each and every aspect that we have to understand about the RPM and how we can understand the what is the RPM of that motor. We are going to learn about that. But the point is that a normal DC motor cannot do that. RPM cannot hold that much amount of strength in it. That is why we are going to use that BLDC. That is the point we have to understand. Okay. Now, before we are going move forwarding to the BLDC, let me introduce a BLDC for you. These are the image. This is an image of a very common BLDC. This is known as a golden motor. Okay, very easy to available in anywhere at your nearest shop or in an open online websites. Okay, so in this session we are going to discuss about all these different type of motors with different structure, why they are different with each other, what are the difference over there. We are going to learn about that. But before this, we have to understand the mechanism behind it. Because without the mechanism, we cannot tell which motor is going to be perfect for us. Okay, that is the most important point. We have to understand the mechanism, how they are going to produce torque, and what kind of propeller they are going to support, how to get the RPM of that motor, according to the RPM, which pitch we need to select for the propeller. These things we have to understand one by one. Okay. So right now, what we are going to do, we are going to see the image of the BLDC. It going to look like this. Now, before I'm proceeding, understand one more point. In DC motor, I told you that this shaft is going to be rotate. Okay, this shaft is going to be rotate like this. All right, and the outer body, this out is going to be fixed in its position. That is clear. Means this is fixed, this is fixed, it's not going to move. But who's going to move for us? Who's going to produce the rotation? This shaft, this rotor. Is it clear? Yes, I hope so. But if I'm talking about the BLDC, if I am talking about the BLDC, the scenario changed a little bit. Now listen very carefully. First of all, see this shaft. This shaft is not coming from inside the rotor actually, because it is mounted with the body. Okay, this is mounted with the body like this. Okay, this is mounted with the body. It means who's going to rotate them? It means the entire outer body. Listen up very carefully. The entire outer body is going to start rotate. That is the first point we have to understand. Means this shaft will rotate definitely, but along with the shaft, the entire outer body is start rotating. Remember that point. And there is one more thing. There is a bottom cap. This one is the bottom cap. I need to change the color. What color I should use? White. This bottom cap is going to fix with the body. This bottom cap just like fan. Yes, you can say that. Just like a fan. Okay, means the stator is fixed, but the outer body is going to rotate. Yes. So the question is that why they do so? Why they are rotating the outer body? What is gonna the benefit for this? First point. Second point, is it there is a kind of benefit? Yes, there is a huge amount of benefit while we are going to rotate the outer body. So before we are going to learn this further, just give me a few seconds so that I can bring a motor for you to demonstrate how it look like. Okay, just give me a few seconds so that I can bring a motor for you. All right. So here we are. Okay. Yes. See, I hope you can see in this camera. Okay. So over here, this is a carbon fiber drone. This is a RC drone. Okay. So let's understand how the motor body gonna work. Okay. There is a propeller, but right now this is an empty motor. And this is the shaft of this motor. Okay. That is the shaft. And now you see along with the shaft, the entire outer body is rotating. Okay. But the bottom cap is fixed with the chassis, with the screw and nuts. Okay. So now you see if I am trying to rotate the shaft, the entire outer body is rotating. Is it clear? I hope you can understand. So now what we are going to do, we are going to fix the propeller in the shaft and we are going to give the nut over there so that it can hold the propeller. And now what's going to happen when we are put the throttle, then the entire outer body as well as the propeller is going to rotate. That is the concept of the BLDC that we have to understand. Now we are going to learn that how the BLDC and why they rotating its outer body. What is the concept behind it? We have to learn this first. Okay. So now let me share the screen again. There we go. So the screen is presenting for you. So right now the first concept is that the outer body contain a number of magnet in it. Okay. Now we see this. Right now we are going to talk about the outer body. So let me zoom the outer body for you first. Okay. There we go. So if we open the body of the motor, okay, so how it is going to be look like? It is going to be something like this. Okay. So now you see these all are magnets. Okay. Technically these are permanent magnets. Okay. So there are several magnets put over there. So if we count, it could be a number of 14 magnets are present over there. Okay. So right now what we are doing, we are we are going to hold the stator coil like this. This is going to be fixed in the same position and it means the outer body having the magnet, it is going to rotate. Why? There are two reasons. Reason number one, when we produce the eddy current, okay, fine. I'm not going to use the technical term over there because there are lots of people who are not belonging from the electrical field. So I'm going to use a layman word. When the motor produce losses, okay, if you running something, if you want to run an electrical device, nothing is 100% efficient. Okay, there are some kind of loss over there. So when it is going to produce some loss, then what will happen? There is a side effect in BLDC. It increase its temperature. Okay, the temperature of the magnet is going to be high. That is the first point. Then what will happen? What we need to do on that time? On that time, we need to cool it down as soon as possible. Then scientists thought, then we don't have extra fan over there. We don't have any kind of extra coolant circulation. Then what we should do? It's very easy. Put the stator in motion. So what will happen when the stator is going to be motion? It is going to create an air drag itself. So when it is going to create an air drag, as well as the propeller is going to throw the air towards the motor, then what will happen due to the metallic surface? Yes, the motor means this motor, the outer body of this motor is made by metal, not the plastic. Remember one thing, okay? Means the outer body, this body is made by metal. So we know that that is a good conductor of heat. So what's happening here? They are producing thermodynamics effect. They are exchanging the heat. So what's happening here? They are going to cool down the rotator, means the outer body, by the help of air. Okay, that is why they put all the magnet at the outside over there and put with the stator body, and then what they did, just start the motor and it is going to cool itself on its own without any problem. I hope you can understand that point. So let's move forward with it. So right now we are going to learn one more point, that how the BLDC works, because that is the most important thing. Because while we are going to learn the BLDC, we have to understand two more points. Because along with the BLDC, there is a circuit, and there is a circuit which is going to play a very vital role. Okay, that is known as ESC. We are going to discuss about the ESC. Okay, but the ESC is going to play a very vital role. ESC means electronic speed controller. The circuit is going to control the speed of that motor. How we going to do this? We are going to explain it one by one in a easy and the most easy language. Okay, so first of all, let's understand how the motor has to be connected with the ESC. First, we have to learn this. So to do this, we have to look this image first. First of all, we have to understand there are three wires. I request everyone, just please make sure you saw all the three wires in the screen. So right now, we saw there are three wires present in the motor. Remember one thing, if we are talking about BLDC, BLDC always contain three wires. Always. This BLDC, drone BLDC, always contain three wires. Why? What is the role of these wires? We are going to explain step by step. The point is that in normal DC motor, we have just two wires, positive and negative. That's it. It's going to work. But in BLDC, why we have three wires? What is the necessity of it? Now listen up. In normal DC motor, we have the commutator, which is going to help to change the magnetic field's position, so that the push and pull is going to be happen over there, means to start rotating it. But in this motor, there is nothing commutator, or there is nothing like this. So we need to change the magnetic field on our own, or by the help of a circuit. That is the point. Means we need, technically we want a help. We want a help from somewhere who is going to change the magnetic field for us. And to change the magnetic field, what we are going to do, we are going to make the winding in a such way. What the way I'm going to tell you. Remember one thing, there are 12 slots that has to be put in this motor. There is always a 12 slot in this drone motors. Okay, why there are 12 slots? Because technically there are three wires, means three different phase we are going to talk about. Three phase. In three phase we need two pairs of coil. Two pairs of coil. Technically, we are going to use four slots in this. Why and how? Let me explain this. So now we are going to understand the wiring diagram of this motor. Why they have three wires and the 12 coils are going to be formed. Now see this. One by one, I'm going to explain this point. So let's do it. First of all, we see over here there are two set of pair has been created and there are two set of pair has been created. So these two set of pair is going to be connect, for example, with the R wire, means with the red wire. Okay. So how many slots we used? Number of slots we used? 4. Similarly, there is a two set of pair. We are connected it with the Y wire, means yellow wire. How many number of slot we used? That is 4. And then we have again two set of slots we used. Now we put it with the R, means B. This is black. And how many slot we used? 4. So now if we total that, how many total slot we use? That is 12. We used 12 slots to make the even distribution of magnetic fields, so that when we are start rotating the magnetic field to create the push and pull method in a outer body, we need to set up the coil like this, and all the three set of wires has been generated so that the magnetic field can be rotated one by one. And for the technical term, I would like to say this is done by the delta connection. Okay, so the delta connection point is for those who are belong from electrical background. But okay, let me explain for the journal purpose also why they should leave behind. They have to know about the delta point. What is delta point? Okay, let me shift the image and let me make a delta connection. What is delta connection? We are talking about three coils, right? So if we are talking about three coils, so how we can demonstrate this? For example, this is my R coil. Sorry for the diagram. It's look like some messy thing. Okay. For example, this is R coil, and then I'm going to make it as a Y coil. Okay. And this is the B coil. So diagram is very messy. Sorry for the diagram, but I hope you can understand. Okay. So right now we have the points from where we can fetch it out. So like this, they are going to give you the connection so that, so this is the, this is for example, first point, this is the second wire, and this is the third wire. That connection they want to produce in this winding. That's it. Okay. All the coils are connected with each other. You are going to energize coils one by one so that you can produce the magnetic fields which help to rotate the outer body of the rotor. That's it. Okay, it is in a simple words. So let's back to the point and let me put the image on its position. So I hope you understand about the structure of the motor, why there are three wires over there, how they placed, and what is the positioning of the coil, why the coil look like this. Now we are going to understand how we can calculate and understand the RPM of the motor, and we are going to learn about the specification of it. Let's begin with the specification. We are going back to the first image. I am putting this image first for you. Let's see. So first of all, what we have here, let me bring it front. There you go. So right now, there is some information written in it. Okay, some information written in it. What is the information? We have to understand it first, because without the specification we cannot understand what kind of motor is it. Okay, means what is the specification, what RPM the motor is going to deliver. We don't know about anything, we are blind right now. So first of all, we are going to learn what are these things. Okay, let me begin with it. The first vital information is this. Let me change the color. It has to be red. Yeah. The first information is this. So what is the first information? It is representing 22, 12. Okay, fine. What is it? We are going to discover it right now. Then there is some more information. It's representing 1400 kV. kV. It means kilovolt, isn't it? Oh my God. Means 1400 kilovolt want, means this motor want that much amount of voltage, isn't it? No, it's very different. Listen up. First of all, we have to understand what are these specifications. Okay, so let me explain this. Similarly, if I'm talking about different motors, means the different one. Which one I'm going to pick? I'm going to pick this one. So over here we see the information is given to us, that is 23 kV. Sorry, 2300 kV. Okay, there we go. And kV from here. And there is one more information by CW. Okay, what is CW? We are going to react on that. As well as there is 2205. The number has been changed. Everything has been changed. What is it? Now listen up very carefully. We are going to start with this number first. This number is going to give you a huge amount of data about the motor. What kind of data we are going to talk about? Listen up. So first of all, if I'm talking about this number, means the 220, sorry, bring it front. Yeah. So we are going to talk about the first number first, this one. So it means 22 represents, if I'm talking about 22 represents the stator diameter. Means what is it? Means just give me a second, I need to change the slide. Means if it is representing 22, so 22 means the diameter like this, means this is the stator width. The stator width is 22. Okay, and 12 or 05 or 04, it is representing the stator height. For example, it is representing 12. So it is representing that the stator width is 22 mm and the stator height is 12 mm. But the question is that why they represent it like this, why we use that, what is the necessity behind this. Very important point. First, we have to understand this. Why they give this information to us. See, technically, if we are going to talk about the size of the stator, means the winding body. If the size of a winding body is big, listen up very carefully. If the size of the winding body is big, it means the motor can able to produce a humongous amount of torque. Humongous amount of torque. If the person don't know about torque, torque means the rotating force. Power means the motor having lots of power for rotation. Now, what we do with the power? Listen up very carefully. For example, if we want to make a heavy lift drone, means we need to make a agriculture drone. If we need to make a drone which can lift a heavy payload, on that time, we need to make a big amount of thrust. What is thrust? Thrust means the continuous jump produced by the motor, means the drag force. So what's happening on that time? We are going to drag a lots of amount of air through the wings. So if we want to drag a lots of amount of air, means we need bigger wings on that time. Yes. So if we want bigger wings, means the weight and the air resistivity of the wing become very high. So to overcome with that thing, we need to make sure that my motor is in a sufficient amount of torque, or the stator size should be in a appropriate match with the propeller. Okay, there are vice versa. For example, if you have a propeller, then you have to see that, okay, I'm using this propeller. Do we have a propeller? Okay, fine, yes, we have some propellers over here. For example, I have a propeller, this propeller. Okay, I have the propeller, but I don't have the motor right now. So I have to check before I'm using this propeller, that is this propeller is good enough for that size of rotor or that side of stator, means the torque produced by the motor is sufficient for the propeller or not. You have to match the specification first. If you have the propeller, you don't have the motor, and now you have the motor and you don't have the propeller, then what you can do? On that time, you have to check the specification that we have a 2204 motor, and in 2204 motor, which kind of propeller we should put over there. Okay, so if you are professional, you know that you can go for 6 and 5 inch. If you are using 6-inch propeller, then you have to go for 4 or 4.5 inch pitch. Or if you are using 5-inch propeller, then that you have to go for 4.5 inch pitch. But the question is that, sir, pitch, and there is still one more point, sir. Inch of propeller, what is it? Don't worry, I'm going to explain. Every point I'm going to explain for you. So, I hope you understand the first point, that the 2212, the 2204, or if I'm talking about this motor, 2205. Okay. Similarly, there is one more motor over here. Where it is? Okay. If I'm talking about this motor, so what's happening in this motor? It's 2204, but there is still one data remain. That is the kV rating. What is the kV rating? Is it really about voltage? No, it's not about voltage. It's something else. Listen up. Just give me a second so that I can take a sip of water. All right. So if we are talking about the KV rating, what is a KV rating? Actually, KV rating represents the RPM of the motor. Now someone thought, it means it is going to give me 1400 RPM. No, still there is something remaining. Now listen up. What's happening with the KV rating? KV rating represents, K actually represents the round RPM. Okay, so technically what's happening here, 1400 RPM means if we are going to put 1 volt, means we are going to put 1 volt, then it is going to rotate 1400 round per minute. That is the point we have to understand. Okay, means what's happening here, if we are going to give 1 volt, it is going to give you 1400 rounds. Similarly, now it's all about the power supply you are going to put in the motor. In journal, in drones, we are going to put 11.7 volt supply, or if the battery is completely charged, it could be around 11.1 volt. Okay, it could be around 11.1 volt. So on that time, if I'm saying that we have a motor which having 1400 kV rating, and we are going to put a 12 volt power supply in it, then it will give you 16,800 RPM. Okay, so if you are going to multiply this value with 12 volt, then you can get the value around 16,800. Similarly, it means if the KV rating of the motor is high, it means the RPM of the motor is going to increase with the voltage. So if we are talking about this motor, let's talk about this one. Okay, just give me a second. There we go. So if we are talking about this motor, the KV rating of this motor is extremely high. 2300. Okay, but see one more thing. When the KV rating is going to increase, the size of the stator is going to be reduced. Yes, that is the fundamental. But you mentioned 12.1 volt. Actually, I just go through the rough calculation. That's why I neglect the 12.1. I just go for just 12 volt. Okay, if you go for 12.1 volt, you can get the value. So I think if for 12.1 volt, I need to use the calculator on that time. It could be around 16,940 RPM. Okay, but there are different type of batteries also, because if we are talking about RC drones, right now I'm not give you the information of battery, so I'm not gonna go with the technical terms, because I need to explain the battery also first, because batteries are also having a huge concept in it. What is a 3S battery, 2S battery, and there are few things over there in batteries we have to understand. So according to the S, the voltage and the power of the battery is going to be decided. Okay, so right now, if we are going to talk about 2300, then we have to multiply it with 12. You can go with 12.1, but for easy concept, I just do with the 12. Okay. So then how much amount of RPM you get at the full peak? It could be around 2300, means 27,830 RPM you are going to achieve at its full potential. But the point is that, sir, is it practically possible that we can achieve that RPM? Now listen up the point. When we are build this kind of thing, we have to understand one point first, that what is the maximum voltage input for these motors, because not all motors is going to work for 12 volt, not all motor is going to work for 11 volt. It could be higher also, or it could be less also. For example, if I'm talking about a small drone, tiny micro drones, they work on only 4, 8, 3, 8.7 volt to 9 volt. Okay. So that is the maximum voltage they have. Or if I'm talking about the smallest drone we can build, means the nano drones. So they just only work on 3.7 volt. That's it. Okay, so right now we are just stepping into the drone. We are understanding the concept of these things, how these things gonna work. Then we are going to learn one by one what is the power rating of these things, how they are going to consume the power. According to the power, we have to put the battery over there. So that's why I already told you there are lots of things behind this drone concept. Lots of things behind this drone concept. That is why most of the people they are trying to build drone, there were some kind of issue they are facing, instability, wobbling, crashing issue, and commands not followed by the drone properly. These things are happened. Okay, because we have to make sure our all point has to be covered by the aspect of the drone, that we should have to put a right ingredient to build the right drone. That's what we want right now. Okay, so yes, that is the thing. So we understand about the size of the rotor, we understand the mechanism of the mechanism of the BLDC, we understand how the BLDC works, we understand how to get the information from the given data on the motor, that yes, this is the motor, and what should be the torque. You can find the torque in the chart, means the specification chart of the motor, that producing is that much amount of torque, and how to match the propeller with it, means the wings of the drone according to the size of the rotor stator. You have to pick your wings. But when we are covering the topic of wings, propeller, on that time we are going to cover the topic of pitch also, because the pitch is going to give you a big trouble if you are going to put a wrong pitch, or if you are a beginner, if you choose a wrong pitch propeller, it's going to give you a lots of trouble on that time. So I hope the concept of BLDC is clear to you. I hope so. Okay. If there is any doubt, don't worry. At the end of session, we are giving you a short, quick review of entire information one by one. Okay. So that is the point. Now let's talk about the second half of the BLDC. Without that component, BLDC cannot work. Yes, BLDC cannot work. We need that component. Who is it? What is it? How it's gonna work? Let's understand. The component which I'm going to represent right now, that is the ESC, Electronic Speed Controller. There it is. This is ESC. What is ESC? Why we use ESC? First, we have to clear the concept. Listen, we talk about microcontrollers, we talk about processors, everything. We understand that yes, they have logic, they can perform these things. But the problem is that they can give the instruction, but they cannot give the current and power supply to the motor. That is the biggest issue. That is the biggest problem. To overcome that problem, we need to make a bridge. We need to make a bridge between the microcontroller. Technically, right now onwards, technically, we are going to call it flight controller. Okay. So, we are going to create a bridge between the flight controller and the motor. Who is going to act like a bridge? ESC, electronic speed controller. Okay, so why we use the electronic speed controller? As per the name, we can justify it is going to control the speed. But how? Who is going to tell when to start, when to stop, at what speed you have to spin? That instruction will come from the flight controller. So now we are going to understand one by one, step by step, how we can connect the ESC, how the ESC works, and how the ESC is going to change the speed of this drone. Technically, yes, you can say that the speed of the drone or the speed of the motor of the drone. So what is the capability of ESC? ESC can help you to put brake on your motors. Yes, there are some ESCs that can help you, give you a braking system, help you to control the speed of the motor. Some advanced ESC having some sensor that help you to find out the RPM of the motor, at what RPM your motor is rotating. And the ESC help the flight controller to send the signal to the motor winding as per the request generated by the flight controller. Okay, these things has been done by the ESC. How the ESC is going to work like this, let's understand one by one. If you want to see how the ESC look like in real world, so just give me a second so that I can show you how the ESCs look like. It's simple. If it is in cover, it's look like something this, okay? So now you see it's having a servo cable over here. Now the question is, sir, why this is servo cable? This is servo cable because it's having plus, minus, and a signal pin. So that is a universal cable which is known as servo cable. Okay. The points are dedicated. Everything is universally set for this. Okay. So this is servo cable. And over here, these are the two input points. Two input points. Okay. Because ESC going to take normal DC supply from the battery. Okay. And after that, it is going to convert all the supply into a three-phase supply like this. Okay. Now you see the output, there is three wires. All right. So if I'm talking about how the internal structure of the ESC will look like, so see this. It's gonna look like this. This is a heat sink. Okay, this is called heat sink. Why this is called heat sink? Because under the heat sink, you see some black elements over there, which is MOSFET. Okay, these are the MOSFET present over there. Okay, MOSFET. In some case, people couldn't recognize what is MOSFET. MOSFET are a component which is a family belong from transistor. So they are metal oxide field effect transistors. Technically, they are. So if I'm talking about MOSFET, what they are doing? Technically, MOSFET act like a switch. Okay, If you want to flow the current, the flow huge amount of current and huge amount of voltage. Okay. On that time, you can use MOSFET for high speed switching also. This is known as high speed switching. For example, you have a light bulb and you are tapping the light bulb very fast. Okay. Means what you are going to do, you are turn on and turn off light the bulb at a very high speed. So by the finger, it is quite difficult to do that for a long time. For a few seconds, you can do that. For a long time, it is very difficult. So on that time, you cannot use a journal transistor or a journal component that can barely go for a little bit of ampere. You need a device or a component that can handle a big amount of current and can handle a high speed switching like this. So while we are doing this, we need either MOSFET, JFET, they are the families of transistors. They help to start switching with the current. Means for a flash of second, you can turn on the current, and for a flash of second, you can turn off the current. Okay. So just give me a second, if I possible, I just remove the outer cover of it. It's very stick. It's fixed with it. It's not removing right now. So if it is possible that I can remove, I just show you how the MOSFET look like. Okay. So I'm going to remove it and then I'm going to show you in next session. But let me share the screen, how it is look like from the inside. So there you go. So let me change the slide for you. For example, we are representing the internal structure of the ESC. Over here, now you see there are 6 set of MOSFET present over there. There are technically 3 pairs of MOSFET placed over there. Means 2 MOSFETs are connected with each other to form a single phase. Okay. If I'm talking about this MOSFET, this one, this pair. Okay. This one. This is the first pair. This is the second pair, and this is the third pair. All right. So what's happening here? By these 3 pair of MOSFET, we creating these 3 section in the technically 3 phase in the ESCs, means the 3 output wires, so that it can connect with the rotor. Okay. So how it is going to work? Let's see. Let me change the slide and put the, I think ESC is working like relay between control the motor. Yeah, in layman words, we can say that, because yes, but actually they are very fast. If you are using either solid state relay, still it is going to damage because the switching speed is very high. Okay, but in layman words, we can say that it works like a relay. Turn on the current, turn off the current, so that for a flash of second, one coil is going to energize, and then all of a sudden the another coil is going to energize. AND gate and OR gate. Okay, AND gate and OR gate. All right, see what's happening here. Right now, this is the winding set. Okay, so we have 3 pair of the set of coils. This is the first pair of coil, this is the second pair of coil, and this is representing third pair of coil. This is a representation. Okay, now what's happening here? Listen up very carefully. First, a PWM signal. Okay, now the word comes. PWM. Full name, pulse width modulation. Again, from the communication background, they know about it. From the electronic background, they know about it. But rather than, I'm going to explain that what is PWM in a journal simple words. This is a pulse. Okay, this is a pulse. This is the height of the pulse. Okay, this is the height of the pulse, and this is the width of the pulse. Okay, this is height and this is width. So as the name represent pulse width modulation means we are going to change the width of the pulse like this. Okay, then what will happen? The height, the magnitude, everything is going to same, but the width of the pulse is going to be changed from the microcontroller. Means in simple and journal language we can say 1 and 0, 1 and 0. What's happening? If we want to give a higher pulse, means we are going to give the 1 for a little bit longer time, means the signal is going to high for a little bit longer time. Then what will happen? The controller present in the ESC is also having a microcontroller inside it, okay, which is which is going to take the information and signal from the flight controller. What it gonna do? It is going to get the information from the flight controller as per the flight controller request, means according to the pulse. It is going to start switching one by one with these relay with these MOSFETs. Then what will happen? It is going to change the speed of the rotation. Okay, that is the point we have to understand. By the help of PWM signal, we are going to tell the ESC that now you have to increase the speed, means when the width of the pulse we are increasing, then we see the speed of the motor is going to increase, because ESC understand the pulse is going to be increased. Now I have to fast the switching. On that time, the RPM of the motor is going to be increased, and when we reduce the width of the pulse, the RPM of the motor is going to be reduced. That is the concept we have to understand. Now we have to learn one more point. What point we have to learn? See. So right now we have to understand how to create the connection with the ESC to the motor. This image representing the lithium polymer battery. Okay, it's representing the lithium polymer battery. Okay, we have a separate session for the lithium polymer battery and the rest of the components and the flight controller also. That session is going to be conducted tomorrow. Okay. So this is the lithium polymer battery. Through the lithium polymer battery, we are going to directly connect the main power lines to the ESC. Now the ESC is getting the full power from the battery, and we are going to connect all the 3 wires like this. Okay. One thing we have to sure before we are connecting. The connection method I'm going to tell you just after few minutes. And now you have to understand one thing. The wire which is the servo lead which I represent is going to out from the ESC like this. Okay. When the sir, great session. Thank you so much. Thank you so much. Okay. So the servo lead is going to out. It is going to give us a 5-volt also. Yes, it is going to give us 5-volt also from the ESC to power up the flight controller or different microcontroller. We can put the power over there. It is going to give us a 5-volt power supply. It is going to very nice and in depth. Thank you so much. Thank you so much. I am trying my best to cover up all the point and aspects so that each and every member in this session can understand about these drones. Okay. So right now we have a negative supply over there. Negative, technically it has to represent that as ground, G and D. So, and last thing is the signal. Okay. So we have to remember one thing. This system is going to give us power so that we can power up our different things, as well as it is going to get current draw from Arduino board. No, it is not going to draw the current from Arduino board. It is going to give the current to the Arduino board. You no need any kind of extra power supply to boot up the Arduino board. Okay, the ESC going to give you output of a 5 volt so that you can power up your microcontroller. Okay, that is the nice presentation. Thank you so much, everyone. Thank you so much. So that is the connection of the motor with the ESC. But there is still few points that I need to explain. But we are going to talk about this in a next session. Means what we are going to understand. Thank you so much, everyone. Thank you so much. So we are going to learn about that thing, means this one. Okay. In next tomorrow's session, we are going to learn the CW and CCW. All right. I think that's all for the today's session, because we are dealing with a lots of information today. And thank you so much, everyone. And this is the very important session for today. And yes, thank you so much. Thank you so much, everyone. Thank you so much. And I wish at the end of the day, at the end of the session, I hope every member of this faculty development program can build their drone on their own. Okay, I wish they can build their drone on their own. Okay, so thank you so much. Today we are going to wind up this session, and tomorrow we are going to proceed with the same information. From where we are going to leave today, we are going to begin from on that point. And okay, thank you so much. Everyone, take care. See you tomorrow with some new energy and with some new information. Thank you so much, everyone, and take care. See you tomorrow. Thank you. Thank you so much.